Okay, hello everybody. Welcome back to chemistry class, or today we can consider this biochemistry class. Usually it's always biochemistry class, but I like to put an emphasis on chemistry because that's where my heart is. So, hello, I missed last week, but I'm back. Even though today has not been one of my best days, I'm so glad to be back with you guys so I can drop some knowledge on you, drop some gems. So, welcome to chemistry class, biochemistry class. And today we are going to talk about sugar, also known as sucrose, also known as other names, but these are the typical names that you guys are going to know the compound by, and it is sugar. That table sugar, that white stuff, or even that brown stuff you pour all over your sugar, everything that gets you going, yummy, and I want some more. We're going to talk about that today. So let's get into a little bit of historical references. Sugar was cultivated or made in Europe. Who knew that? And when I did a little bit more digging today, I want to know specifically where. It was Portugal. And sugar didn't come into existence or being cultivated in the United States until the 18th century around slavery time because of the free slave labor from me and from some of you guys' ancestors out there. So that's a Black History fact for Black History Month. Power to the people, okay? But let's get into some chemistry of sugar. So we're going to recall a couple of things that we've been learning over the weeks. We're going to always be referring to, for the most part, our pH chart, which is going to tell us from 0 to 14. It's going to let us know what's acidic, what's neutral, what's basic. You guys should already have that down packed by now. So sugar or sugar cane juice, let's refer to the juice that comes from the sugar cane, is going to fall somewhere between a 4.5 and a 5.5 pH. And you guys already know where that falls at. Where does that fall at? The acidic range, okay? So when you think of sugar, sugar cane juice was produced from the sugar cane, you're going to think of sugar, 4.5 to 5.5. pH is acidic. So let me take you guys back up here to give you a little bit more information about sugar and where it comes from. So 75% of sugar is going to come from the sugar cane. We all know sugar cane. I used to eat or chew on sugar cane sticks when I was a kid, and it was so good and made you want some more because sugar always leaves you craving for some more. So sugar cane comes from sugar cane grass. As you can see, this is my images, but this is the grass. Also, it can also come from sugar beets, but the percentage of sugar that we're going to be eating, I don't eat sugar, but the percentage of sugar that you guys are going to be eating out there, if you do eat sugar, is going to come from the sugar cane. Okay, so what is sugar? Sugar is it man-made? Is it natural? What is it? Well, have you here? I'm going to answer your question. Stick with me. Sugar cane, or that we get the sugar from, is a disaccharide. This is how we describe sugar molecules in chemistry. We say that it's a disaccharide or a monosaccharide. Monosaccharides are what you want to be eating or consuming. You don't want to be consuming disaccharides. So, for example, sugar is a disaccharide. It contains glucose and it contains fructose. Fructose, as we know, is our fruit sugar. So it contains both of these compounds of sugar, which makes it a disaccharide. A monosaccharide would just be glucose, fructose, or galactose. But a disaccharide contains them both. So we have to think of what combines them to contain them both. Okay? Think of that when you think about something that is not man-made or something that is created. So sugar. Let me get into some facts about sugar. So sugar cane is hybridized. And when I say hybridized, that means that it's man-made or man interfere in the process in order to grow it. So it's grown in a vegetative state. When we think of what is natural or not hybridized, man-made, is that something that grows strictly from the ground that doesn't need interference of man to what we call cross-pollinate, which is hybridizing or the combination of one species with another species that would not normally grow together. That's what hybridizing is. So sugar is a product of hybridization. How is it a product of hybridization? Stick with me, okay? Don't you lose me out there. Come on now, guys. So I got some notes today, so bear with me. So it's produced by a vegetative state. And that's going to mean that they're going to take the stems and they're going to use the stems, do some mixing and mingling with the stems. Then they're going to take the stem and they're going to plant the stem into the ground, not a seed, because sugarcane doesn't produce a seed that could produce itself. That's another way you know something is hybridized. If it doesn't produce a seed that produces itself, something is wrong with that. For example, a carrot. A carrot doesn't produce a seed that produces itself. But we're speaking about an apple or a grape that is seeded. You take that seed, you plant it into the ground, it's going to produce itself. So when it doesn't do that, that's another indicator that something is hybridized, okay? So by the vegetative state, meaning that it's going to take the stem, put the stem into the ground, the stem is going to grow. And it's not going to allow the sugarcane grass or the plant or tree to actually flower, to become a flowering tree or a flowering plant, because in that process, if they allowed it to flower, the sucrose would deteriorate and the cane would dry, so you wouldn't get sugar out of it. This is why they do this vegetative state process in order to plant and produce the sugar cane, okay, and to get the sugar from it. Anyways, getting off of that, remember that sugar comes from sugar cane or sugar beets, mostly sugar cane. Sugar cane is a grass. Sugar, also known as sucrose, is a disaccharide containing of two sugar molecules, which is glucose and fructose. But most importantly, our takeaway is that sugar cane juice is acidic, falling somewhere between a 4.5 and a 5.5. And that's a hybridized product, meaning that it's not from the ground and given to us by the universe, or some people would like to say by God. That means that man has to go in there and engineer it and play around with it in order for it to grow. That's hybridization in the short. So, sugar cane is highly addictive. Or sugar, let's say sugar. Sugar is highly addictive, more addictive than cocaine itself, because sugar acts on our opioid receptors in our brain, which means it binds to the same receptors it would if you were going to take an opioid. You're going to take a Tylenol with codeine 3, some morphine, anything like that is going to bind to the same receptors. So where it's going to bind to outside the opioid receptors is going to affect the hypothalamus. So the hypothalamus is right here in the brain. You can see this picture that I'm speaking of, this green little pea-sized button is the hypothalamus. The hypothalamus is the reward center. So when you intake sugar, it's going to interfere with the processes and functions that the hypothalamus does. And the hypothalamus is going to, one of the functions, particular to talking about sugar, one of the functions is going to be that, it's going to be that it's a reward center. Not only is it our reward center, but it also focuses on glucose homeostasis. Homeostasis, just think of balance, think of equilibrium. Like when someone says your equilibrium is off, that means that you're unbalanced. So just think about that when we say homeostasis. So it's supposed to function as a glucose equilibrium or balancer. So when you're eating sugar, you're going to interfere with the functions of the hypothalamus. It's going to excite this reward center, and it's going to make you crave and want more. It's going to be become very highly addictive. That's why you see people eating so much, overeating. When they're sad, when they're emotional, they eat because they have this craving. It does something to them when they eat it. Also, what else do you see when people say that I got the sugar? Like old people say I got the sugar, I got the sugar. Some people say I got the gout, but some people say they got the sugar. Two totally different things, but we think of diabetes, another chronic disease that plagues our community. When I say our community, I'm referring to me, Black people, African Americans, however you like to describe it, the Negro. So diabetes, you can have a hypoglycemic, hyperglycemic, you can depend on insulin, non-insulin dependent, but whatever form, that means that you're having some difficulty with glucose. Another product that has a lot of sugar in it is going to be cigarettes. Cigarettes have a lot of sugar, and Dr. Sabi teaches us this, that sugar is contained in the cigarette, which makes it highly addictive, which is why people cannot kick the cigarette habit because of that crave. So sugar is very, very addictive. More addictive than cocaine, and also in cigarettes is why people are hooked on it. Another fun fact is that sugar feeds off of yeast. So this beautiful vajayjay right here that I drew is basically just to tell us that when a female has reoccurring yeast infections or she's having issues down there with yeast, the first thing I would think about is, are you eating a lot of yeast? Are you eating things that contain a lot of yeast? And are you eating a lot of sugar? Because sugar feeds off yeast. So if you're having a lot of yeast infections, are you drinking a lot of alcohol? Are you drinking a lot of products that contain sugar? Are you eating a lot of foods that contain sugar? Are you eating a lot of foods that contain yeast? Which a lot of people eat a lot of bread, liquor. Liquor has a lot of yeast. Fermented products, fermented drinks have yeast. So that would be one thing you would really want to cut back on if you're having issues with yeast. Yeast begets more yeast. Sugar begets more yeast as well. Stay away. So I think that's it, ladies and gentlemen. I think that's all we're going to talk about today. So this is going to be a very short class. Like I said, I did not have a lot of time to prepare, but I didn't want to leave you guys high and dry today. So what I'll do, I'll take pictures of chemistry class board so that you guys can see a little closer, just in case you can't see it from right here. But as I said, some takeaway, let's start from the beginning. We have sugar, which is sucrose, our table sugar, which mainly comes from sugar cane. At least 75% of the sugar we're getting comes from sugar cane, which is a grass, hybridized and processed in by a vegetative state, or we can get sugar from sugar beets. But we typically are going to get sugar from sugar cane. Sugar cane is acidic, falls somewhere between a 4.5 and a 5.5 on the pH chart, making it acidic. It is also a disaccharide. We describe what saccharide means. We describe what mono means. We describe what disaccharide means. Saccharide referring to sugar. Di or mono as a prefix referring to how many molecules it is. So disaccharide meaning it's going to be two molecules. Those two molecules are glucose and fructose, which make sucrose. These are just the chemical names, but sucrose, sugar, glucose, fructose, fruit sugar, disaccharide. And what are the chronic diseases or illnesses that can be associated with high sugar intake or just sugar intake? We have diabetes, that stands out as one of them. Also, that sugar is highly addictive. It interferes with the hypothalamus, the reward center of the brain. More addictive than cocaine. It binds to the same receptors as opiates does in our brain. Fun fact, where was sugarcane cultivated? Europe, Portugal to be exact. And the vajayjay, this beautiful creature, is affected by sugar because the more sugar you eat, the more yeast can be affected by that. So sugar begets yeast, so we don't want yeasties. That's not fun, ladies. We all know that that's not fun because that can be very icky when you're trying to have some fun. Okay, so this is chemistry class, and this was sugar. Hope you liked today's class. And if you have any questions, you know that you can always drop a comment. You can email me. You can find me on Instagram, and you can drop me a DM, or you can ask me questions on there. Wherever you can find me, I'm available, and I would love to interact with you guys. So please let me know if you enjoyed chemistry class for today, and I'll see you next week. Also, let me know what you guys want to talk about. Sometimes I find it hard to find subjects that my brainiac nerdy self loves, not just you guys. So I want to make sure that I'm fulfilling your needs and that you guys are learning. I just don't want to be sitting up here talking for my good. So if you're using this information that we've been posting, please let us know. We would love to hear from you. Peace. You know I love you guys, and hair grease.